This is a T1 channel bank. Back in the day, this could handle 24 calls at the same time. If you took 28 T1s, they made up a T3, which could do 672 calls. The same line now can hold millions of calls without much changes on the back end. Voice over IP technologies allows businesses to save thousands of dollars a month by allowing you to run it over the same networks and not have to pay for these multiplex lines. However, due to the nature of VoIP, it's one of the hardest services to actually bring to a client. The reason being, it's a real-time nature. As I talk to you, if I lose any of the network, you're going to hear it. And there's no buffer like in Netflix where it'll just queue up. Everything is real time, so your network has to be perfect. We bring voice communications to our clients by the VoIP protocols. In this video, we're going to show you how we do it. I'm Brock Bites, and I run the internet. Just a little over 10 years ago, most communications were done by this, and I spent my life trying to troubleshoot this. I swear it's taken years off my life trying to get all the timing work, since it is all by time. So all your clocks had to be correct. So I'm actually going to break this, because I hate these. So for our VoIP services, there's two services we provide. We provide phone lines, and we provide PBX systems. A PBX system is like when you call up any service and you get a menu, you press 1, you hear someone, they tell you what to do. All that's done by a PBX, or private branch exchange. These will do phone lines. So you can take any of your phone lines in your house that currently exist, plug them into this, and you can get a regular dial tone. Now, if I just take one of these, hook it up to our network, disconnect the phone line that goes to your house from your local voice provider, I can plug in this to your house and all your phone lines get energized over VoIP lines now. So these are some of the things for a PBX system. We'll have your headsets like this. These are all powered over a switch like this. The network is super important to allowing us to have VoIP. We have to prioritize VoIP packets throughout the whole network, which means that we have to start on our core routers, go through our aggregation layer, all the way up to any distribution points, all the way into people's house or businesses, and make sure that this has its traffic prioritized the whole way through. If it's not prioritized, then when you start downloading a big file, it's going to use all the available bandwidth and you're going to sound like a robot.
Like a robot.
So one of the things that's super important and critical to the network is the amount of latency and jitter. Latency is the time it takes to get to the client, and jitter is the variability of the time between the packets. So if one packet takes 50 milliseconds and then you got one that's 100, that's 50 milliseconds of jitter between them. Now that increased jitter time, if you go 50 milliseconds, 100 milliseconds, 300 milliseconds, 200 milliseconds or something, that'll cause all sorts of disruption as you hear the voice, and it'll sound like a robot.
Like a robot.
So we make sure that everything is prioritized to make sure the packets get it back in order and in a good amount of time. The other thing that's super important to this stuff is that it's always available. If you dial 911 and you have an emergency, you got to be able to reach 911. So things that we do to guarantee that things are always up are, we have multiple servers running these services for voice at one data center. So we'll have like 2 computers, and if one of them fails, it moves all the stuff over to the other server. Now that's great for just here, but what if the whole data center dies? We actually have all these things running in a separate data center, so if the whole data center dies here, it automatically goes over there. It can be the difference between life and death if it doesn't. Of these components, there's a lot of subcomponents that make this phone system work. If this call wants to call this, the first thing it needs to do is it has to know its config. So it's going to first boot up, figure out where the server is, download its config, and make sure that it's on the right firmware, and then reboot. That's called the provisioner. Once it has its provisioner, it's going to hit a proxy server. So when you press dial and put in the number, it hits the proxy server, and then it says, hey, I'm ready to make a call. So that proxy server is also what talks to the PSTN, or public switch telephone network, the thing that actually provides the dial tone. So that proxy server will take the call that you've set up, the initial call setup, talk to the phone system and link those two together. Once that's been done, it hands it over to another server. The next server is called the media server. When you actually hear the ringing of the dial tone and everything, the media server is what's actually playing that back. Also, if you have to do any transcoding or anything like handling any protocols, the media server is going to actually be the one doing that. Lastly, it detects when the call is finished and it'll actually hang up. And then your phone call is pretty much done, but there's other things that are helping these things along the way. So the application server is the thing that actually handles the call routing and the call flows and what happens when you have a PBX. When I pick up and say hi, and it says, hi, this is XYZ Corp, who would you like to answer? And you press 1, that's the application server that's routing that call. So once you do that, that application server also handles things like eFax, where a fax will send it up to the application server to process, and it'll send it to you by email. Hooking up a traditional fax machine to one of those things called an ATA doesn't work so well because of the tones that are involved. It can't see them on the digitized system as well, and you don't get that fast throughput, and you get drops and you just have problems. So using an eFax manager simplifies everything, and it's a lot more convenient for you by having it in your inbox rather than going to find a physical piece of paper. Lastly, it'll do call recordings. Like, we record everything on our system for callback purposes, and we have a person that's just listening to the calls to make sure everything's good. The thing that's actually doing that is the application server. The last part of the system is the database server. Each one of these things is hitting a database for call logging, to store all these things like menus, to store all the calls. Everything's stored in NoSQL database across all our data centers and computers. These things are all kept in sync by replicating all the data amongst them at the same time. So if something does happen, it can be built from any one of these databases. You can recover everything. VoIP gives you the flexibility to really use any kind of phone, whether it's an analog phone, whether it's a digital phone, whether it's a PBX system, all combined into one system so you can keep your past investments from prior years. Here's just a few of the different phone systems we use. Everything from an intercom system, like a PA system at a warehouse, or you can have a conference system where you actually just press a button and you can all talk and you can all listen at the same time. It has a lot of sound processing it has to do. Some of the other things that we provide are regular headsets with a lot of buttons. Now, these buttons are mostly just for like secretaries that want to transfer calls to them, but they're really flexible, and you can use just about everything that you invested for in the past with today's modern systems. Last month we did a casino that had a few hundred rooms, and to do that they had all these analog phones all through the property. It'd be impossible to change their Cat3 wiring that traditional phones use for Ethernet, that all your modern phones use, because they also have to provide power. So they make a big ATA that will power everything there. So we were able to move all 200 phones onto our phone system that's hosted over here at this casino, and able to power everything just like it was seamless transition. Lastly, we had to have a music system all throughout the property. So we hooked up something like this, where all you have to do is hook up some stereo wire, and then your phone system will be able to play throughout there. This transition was done in less than a day, and it was super convenient for them. The administrative work for phone systems is immense though. It's not just something that you can plug in and start working. You have to fill out a lot of forms to get this working, such as your 911 forms, if you have a phone number that you want to keep and want to port it over, or if you have certain call flows or have whatever you want to have work in a certain way, it's all manually programmed. It doesn't just work. So everything we do, we have to have someone that's constantly checking for forms and filling out the system the way that people want them, so that the system will work the way the customer wishes. If we don't, we can be legally fined. If the 911 stuff, if someone calls 911 and they're not there, we get a fine. Or if something doesn't work right, we have to make sure all this stuff is exactly as they want it to. Because if you hit 3 and it goes to 5, you can really screw up someone's day. So since these PBX systems are all digital, we can create a lot of cool functions for them. So we built a lot of custom software programs, such as our portal, that allow a client to log in. They can manage their voicemail, they can download anything from there, they can text from our voicemail center, they can change call flows or caller IDs or whatever they want through one simple portal. One cool thing that we did write is when a call comes in, it queries our database for any customer with that caller ID, And it'll bring up everything it knows about that customer within a convenient portal. So that if you have a trouble ticket with us, it'll automatically bring it up just by calling us, and support can give you better service than anyone else. Within our software also, after you bring up a trouble ticket, everything that you said on the call is also logged to that client page. And we have someone that just goes through all these quality assurance calls and makes sure that everything rates well. So because of the real-time nature of all this stuff, we have to be able to go look into the past and see what happened. A lot of times people will misdial a number and they won't realize it, so we are able to store all the numbers and all the metadata about a call. But we actually store a lot of the information that actually goes through the phone system, and we can actually rebuild calls based upon a lot of this data and see what happened, whether it's from something on the protocol layer, the application layer. We are able to diagnose what happened. For instance, here I'm going to call my cell phone. And I'm going to record something into it. So I'm recording. This is my voice. And now I'm going to hang up. And then from my computer over here, I can rebuild the call from the packet data because it's all data now. I can play the stream, and I can see exactly what happened throughout the call.
Record something into it. So I'm recording. It's my voice. And now I'm going to hang up.
So this enables us to check what happened in the past. Even though everyone has a cell phone, businesses and all your critical communications for your business rely upon these VoIP protocols. Most of the cell phone technologies at its heart are based upon all these VoIP protocols. If you have a business that you want to collaborate, or especially in today's times work at home, all you need is take this to my internet connection and I can get online and people won't know that I'm in the office. I can be anywhere. So especially with COVID, we're able to provide a service that people need to be able to work and still maintain a normal way of life. If you hear anything broadcasting over a speaker, chances are it's a VoIP protocol. If you look around, I'm sure you'll see them everywhere.
Like a robot.